Hello, everyone. Welcome. Thank you all for joining us for today's Tech Talk. Please hold off any questions until the end. And now let's all give a warm welcome to our speaker, Katie.
Woo! Yeah. Yeah.
All right. Hi, I'm Katie, and today I'll be talking about Apache HTTP Server and NGINX. But first, I'd like to thank our sponsor for today's talk, Single Sprout. Okay, so as I mentioned, we're going to be discussing the pros and cons of Apache and NGINX and doing a comparison. Here's our agenda for today. So we're going to go over web servers, reverse proxies, server architecture, load balancing. We're going to discuss Apache in detail, NGINX in detail, and compare the two, talk about some design considerations, look at market share for Apache and NGINX, and then go into a summary. So you can look at your simplest model of a web server as clients accessing a website, a server to process those back-end and front-end requests, and a database to store data. So it looks pretty simple. You got some smartphones, laptops, desktop computers, all coming in to just straight into your server, accessing the database. Cool. So while server architecture can seem simple at first, it can get complicated quickly. To the right is a diagram which attempts to explain part of the server architecture for Netflix. So as you can see, it's pretty complicated. There are a lot of things going on there. There's replication of different services. You have a lot of things pointing to different things. So in the next few slides, we're going to be discussing a few tools that can be used in server architecture. These are load balancing, clustering, caching, proxies, and reverse proxies. These are just a few of the most common pieces used in server architecture. Okay, so first, load balancing. So load balancing is basically a thin layer that takes incoming requests and tries to evenly distribute the load between a back-end element and a server, like a server, a database, etc. So NGINX is very commonly used for load balancing. And you can load balance at all over your server architecture. So you want to load, if you want to load balance between the client and the servers that you're using, you can do that. You can also put it in between database. So there's a lot of flexibility there. Next, we're going to look at clustering. So this diagram is from Servoy, which is a tool used for clustering. And clustering is basically when you have copies of the same server. It provides availability, reliability, and scalability. And it's almost always used in conjunction with load balancers, because when you have multiple servers that are basically functioning the same, they're copies, you need something to direct the traffic to which server to choose between. Next, we're going to get into caching. So caching stores frequently accessed data in active memory so that the server can bypass retrieving data from the database. So if you think about something like a commonly accessed tweet from Kim Kardashian, we don't want to spam the server every time somebody tries to look up that tweet. We can just cache it instead of going into the database and looking it up every single time. Next, we're going to talk about proxies and reverse proxies. So they're fairly similar, but proxies redirect outgoing internet traffic through a different server. They're used for security and obscurity. The traffic goes out from your network to the internet. Reverse proxies redirect incoming internet traffic to a different server in an internal network. They're used for security and obscurity as well. A common application for reverse proxy is a local intranet, and the data is going to be coming into your network from the internet. So the initial release of Apache was in 1995, but the C10K problem of process-based server architecture was what led to solutions like NGINX. And so you can see a timeline here of how things evolved. Okay, so here we're gonna dive into Apache. So Apache is what you'll see as part of the LAMP stack. This means Linux, Apache, MySQL, and PHP, or it could be MariaDB, MongoDB, Python, Perl. You can kind of mix and match here, but the key is like Linux and Apache as well. It first came around in 1995. It's easy to install. And this is the key piece here. It's threaded. So for each connection, we start a new process. This is like its own event loop, so it's non-blocking for other connections. It's modular. It's designed to be extended and customized. No restart is required for changes to the server. The numbers vary, but agree that Apache is the #1 in volume for number of websites using Apache. Okay, so let's talk about the C10K problem. So this is a screenshot I took of a website that's still alive today. Kind of looks like it's written in the 90s, because it was. And this is the description of the C10K problem that we're discussing. So the C10K problem is the ability to handle 10,000 connections at a time. And this phrase was coined in 1999 by Dan Kegel. Today, internet speeds are much faster and the number of concurrent users for a popular site is much higher than 10,000. So if we kind of zoom in on this data, these numbers are a little bit ridiculous in terms of compared to the scale that we're looking at for websites today. And for context, JavaScript first appeared in 1995. Prior to that, websites were static pages. So here's what Amazon.com looked like in 1995. So you can see it's pretty static and it looks pretty different from Amazon.com today. Okay, so NGINX. It uses much less memory than Apache. It doesn't rely on threads to handle requests. It's an event-driven architecture, which is why it uses less memory. And that makes it much more scalable. It's focused on high concurrency, high performance, and low memory usage. It's part of the LEMP stack, and we say LEMP because LNEMP is kind of hard to say. So the same thing, we're talking about Linux, NGINX, MySQL, MariaDB, Python, PHP, Perl, whatever you want to use there. It's also used as a load balancer, HTTP cache, web server, origin server. It's well supported by the community. It powers Netflix, Hulu, Pinterest, Cloudflare, Airbnb, WordPress, GitHub, SoundCloud, and there's countless other popular sites that we use. So while estimates on market share vary widely, it is clear that Apache and NGINX are the most popular options for web servers. Apache leads overall, possibly due to its first mover advantage. NGINX leads in larger, more used sites. This is likely better due to better horizontal scaling. Okay, in summary, Apache and NGINX are fairly similar in terms of features, cost, and flexibility. The real design consideration is whether you will be performing data-intensive calculations on your server. If so, go for the threaded process-based architecture of Apache. If you're more concerned about handling a high number of concurrent connections, go for the message-based architecture of NGINX. And that's my talk. Thank you for listening, and I'll take any questions you have.
Woo! Katie.
Okay, thank you so much, Katie, for a wonderful talk. We will now have a brief Q&A. Please use the raise hand feature if you have any questions. All right, so we'll take our first question from Hei-Jin.
Hi, Katie. Loved the talk. I came kind of late on accident, so I might have missed some important details, but you mentioned how NGINX has better horizontal scaling than Apache. Is this just, I'm not sure how server companies work, but is it because they just have more servers to like dole out, or is it something to do with the message-based architecture?
So great question, Hei-Jin. It actually is due to the message-based architecture. So when you look at Apache, it's threaded. So every time a user hits an Apache server, it creates a new thread and operating system process for that user. However, in NGINX, it's an event-driven architecture. So every time a user comes in, they're kind of like put in a queue. So NGINX has a certain number of capacity, and it's sort of fixed, which means that if you want to create more servers, that's pretty easy to do. Whereas Apache, you're going to have to do a lot more processing on that end because it's just heavier to have an actual operating system process startup for Apache. So NGINX puts everybody into a pool, whereas Apache treats everyone like VIPs. You know, okay, you're here, let me give you your own OS process.
Okay, thank you.
Okay, and a question from Vivian.
I know you mentioned it earlier, but can you go over or clarify the difference between forward and reverse proxies?
Sure. So you can think of proxies as one-way gates. So proxies are designed to only allow a response when there's a corresponding request from an allowed source on the correct size. Proxies and reverse proxies are fundamentally the same. However, the use cases are different enough that you would discuss them in a separate explanation. So it's basically looking at the origin of traffic that determines whether it's a proxy or reverse proxy. So reverse proxy takes in incoming traffic from the internet. A proxy handles traffic which originates in your network.
Thank you.
And we'll take one last question from Greg Pansiera.
Hey, Katie. I was curious, you mentioned NGINX can be used as a load balancer also. And I was wondering where load balancers like reside. So like if you've got a load balancer to distribute traffic to your server, like where does that actually live?
So
is it on the server?
Yeah, so it's kind of going to be something that you'd hit before you get to the server. So the load balancer is going to decide and keep track of which servers are available at the time, where it sent traffic recently, which servers are currently working on a lot of tasks and things like that. So it's kind of put in between. If you want to put a load balancer between a server and a database, you can, or several databases to choose between them. So it's kind of a middleman, if you can think of it like that. Yeah.
So if you punch in a URL, like that might go straight to your load balancer, and then that would in turn feed off to whatever separate servers maybe you have.
Yeah, that's correct.
Got it. Awesome. Thanks.
Okay, that concludes our Tech Talk for today. Thank you all again for joining us and have a wonderful evening.